promised today, I said I would give you guys a video. As promised today, I said I'll give you guys a video for going over that test question that was posted on the College Board website. If you don't know what I'm talking about, check the email I sent out earlier this week or Sunday. And there's that link to the College Board website. The first link posted in the email. Go there, scroll to the bottom, and you'll see the sample question on there, and that'll get you where you need to be. Going over this, I'm going to share my screen here if I can figure out how to do that. More actions. I'm going to just share screen thing on here. Ooh, is there not? Share. Oh, there we go. Okay. All right. So hopefully this is sharing now. You can see on question 2 here that's posted. It shows this question that brings up students plotting genetically modified corn on one half of a plot of land and regular corn on the other half of a plot of land for 33 different plots of land. And it shows us the mean, standard deviation, n value, which remember n is our size of the our sample size. And then we have minimum, Q1, median, Q3, and maximum values. And so this is for the genetically modified corn, the regular corn, and the difference between the two. So what they're doing to find the difference is they're taking the yield for the half plot that's genetically modified. So let's say if I have 126 bushels on the half plot on the genetically modified half, and then I have 120 bushels on the regular half, I would take the 126 minus 120 to get a difference of 6. And so they're doing that for each of the 33 different plots of land, and then finding the mean, standard deviation, all that good stuff for that. So if we look at question A here, it says explain why the yields from one type of corn are not independent of the yields from the other type of corn. Now, remember, it's completely acceptable to explain this using logistical reasoning. If you remember, we had the mathematical formula for determining independence, which was for two events to be independent, meaning one does not affect the other, right? So meaning my growth of genetically modified corn would not affect my growth of regular corn or vice versa. The probability of one given the other, so in this case, maybe the probability of having genetically modified corn given regular corn has to equal the probability of having genetically modified corn times the probability of having regular corn. So if I'm thinking about this, right, this seems like it'd be kind of difficult to calculate, right? Because I'm not really sure what the probabilities are going to be looking at this data, right? So when I was going through solving this, I spent quite a bit of time racking my brain, trying to logistically think of how to calculate that. But then I remembered what's the word I'm looking for? The logistical reasoning behind it. So the non-quantitative reasoning of why one might affect the other, and there's multiple reasons of why one might affect the other, right? Maybe the genetically modified corn grows a little bit higher and takes up more sunlight from the regular corn, so that would affect the amount of bushels that are able to go, right? Because maybe not as much regular corn is able to grow because it's not getting as much sunlight. Maybe the genetically modified corn takes up more water than the regular corn. So, the regular corn's not able to get its water, right? So those are just two things you could use to possibly explain that for that. So that's the type of answer that I would put. And remember, we're able to use that reasoning because we're taking one plot of land, splitting it in half, and putting genetically modified on one half and regular on the other half, right? So those two things are so close together that it's likely that one could possibly affect the other, right? So we can't assume independence there because of that reasoning. And so for the second question here, it says, based on the summary statistics, would it be more likely to obtain a yield of 123 or more bushels per acre from a plot of genetically modified corn or a plot of regular corn? Justify your answer. So I'm going to switch back from sharing my screen here. If I can get that. Oh, what did I just do? There we go. All right. So hopefully my screen share is not going on anymore. Or actually, nope. There we go. Now it's not going on anymore. So I'm going to show you guys what I have here on my paper, and then I'm going to actually take a picture of this and send it to y'all with the email as well. So if we look at this here, I have that the mean of the genetically modified corn, which was given to us, is 125.018, and that's given on that table there, right? The mean of the regular corn was 120.482. So since the 123, right, is greater than the mean of the genetically modified, or sorry, is less than the mean of the genetically modified and greater than the mean of the regular, then the genetically modified is more likely to produce greater than 123. So the reason why we get that genetically modified corn is the odds of genetically modified, or the genetically modified have a greater odds of producing more than 123 bushels in a plot of land, is because if we look at the means, right? The mean of the mean of the genetically modified is 125, right? So if that mean is 125, and I want to see which one has a greater odds of producing more than 123, right? Well, if the mean's 125, isn't that higher than 123? So wouldn't that suggest that there's more values greater than 123, right? And then if I'm looking at the mean of the mean of the regular is 120. Well, that's less than 123. Wouldn't that suggest that there's more values less than that 123, right? So if I'm looking for at least 123 or greater, I would go with the genetically modified corn. Question C. I'm gonna go back to screen share here. Give me a second. There we go. All right, so question C asks us to describe the distribution of the differences. So, so in order to describe the distribution of the differences, I'm actually going to just stay in screen share and explain this one. So all I really have to do is just explain what's going on with this box plot, right? So this left side is my minimum value, right? This first thing is Q1. This middle thing is my median, Q2, or Q3, sorry. And then maximum here. And then remember this circle outside of the maximum value that's marked is actually my true maximum value, but this is considered an outlier, right? So one thing that I need to remember when describing this, right, is that I don't have all the data on my table here, right? I only have some of my data, right? I don't know each individual number. So since I don't know each individual number, right, I'm not going to know things like exactly how many outliers I have, how many data points fall between, the median and Q3 and so on and so forth, right? But I can make some assumptions about the distribution. So one of the assumptions, or one of the things I can use to describe the distribution, is that there are more positive results, right? So meaning a higher genetically modified yield than a regular yield. So if I'm looking at this plot here, right? So there are some values less than 0, right? So that means that since there are some values less than 0 here, then that means there are going to be some instances of the regular being higher than the genetically modified, right? But if I look at the whole of this, isn't most of this data greater than 0, right? So I can assume that there are more results of genetically modified producing more than regular corn. Another inference I can make is that the data is positively skewed. So remember, we talked about skews, right? And we can determine skews looking at the mean and the medians. So if your mean is higher than the median, then that's a positive skew. If the mean is less than the median, then that's a negative skew. So if I'm looking here, my mean, right, is 4.5 about, and my median is 3. Wasn't 4.5 greater than 3? So I would say that this is a positive skew. And then the third thing I put down is that there are outliers present, right, on the positive side, but I'm not sure how many, right, because I don't have all of the data. So since I don't have all of the data, I can't safely assume that, or I can't assume how many outliers there are, right? But I do know there is at least one. There could be many outliers for all I know. So the next one we had is question D. Let me flip over here. There we go. All right, so it says one of the conditions. So this is kind of where we're starting to get into things that we didn't get to cover, which so that's why part of the reason why I like this. So I will say, I really suggest that you guys, and I'm actually going to bounce back here. If you go to this Fiveable website, which is the second link that I sent out, if you scroll down to the bottom here, this Unit 6 and Unit 7, I would spend a lot of time over the next few days looking over those two units in particular, because that's going to be data that we haven't gotten to go over yet. That's going to be on the test. The rest of this we've actually gone over, so spend some time just kind of skimming over it and making sure you're familiar with it. But really focus on these two units here. I mean, and I would watch as much of these videos that are on here as possible and everything. Now, what I will say is it's not like you'll see on here, it'll talk about p-test and we'll talk about p-test here in a second. And you'll probably see these like weird charts, like the z-score charts and everything that we had looked at the beginning of the semester. Don't freak out over calculating that, because there's on such a limited time for this test. There's not going to be a ton of hard calculations. And remember, right, we're not they're not expecting you to have a scientific calculator. So since they're not expecting you to have a scientific calculator, they're not going to expect you to go through all these z-score tests and all that stuff, or the p-test and all that. They're just expecting you to know how to work with it. So as long as you're familiar with working with it, and remember, it's open notes. So if you go through all of this stuff and remember where to find things at, right, you can pull this website up while you're taking the test and skim and scan for material that you need. So definitely spend time looking at units 6 and 7 on the Fiveable website. So now with that being said, going back to this guy, it says one of the conditions for inference that was met is that the sample size of the differences is greater than 30. Explain why it is necessary to satisfy this condition. So this actually goes back to something that we did cover though. And I'm going to go back to not sharing my screen here real quick. Stop sharing. There we go. All right. So I'm going to pull up my sheet here. Actually, I'm going to talk for a second. I'll pull up my sheet. So if you remember, we talked about normal distributions and stuff. So in this case, we pretty much always want to assume normal distributions unless we're told otherwise, right? So in this case, we're going to assume a normal distribution, right? And in order, and with the normal distribution, we had that 10% rule. So the 10% rule was that n must be no more than, or sorry, n must be more, wrote that wrong. N must be more than 10% less. Oh, sorry, no, I had that right. N must be no more than 10% less of n observed. So if we go back to this question here, and I'm going to pull it up on my screen. You won't see it on your end. It says one of the conditions for inference that was met is that the sample size of the differences is greater than 30. So if you remember, we have to assume, so I said earlier that n must be no more than 10% less of n observed. So my n observed was at 33, right? So I had 33 different plots of land. So since that is 33, I can take 10% of 33, which I calculated here. Let me see if I can. So question D. So it's so you can kind of see what I wrote down here. And remember, I'm gonna take a picture of this and send this to you guys, so you'll be able to pull it up on your end and see it as well. So it says n observed is 33, right? That was at 33. So I'll take 33 times 0.1 is 3.3, right? 33 minus 3.3 is about 29.7, which is about 30, right? So that's where that's how you would prove that solution, the work you would show to prove that solution or to prove that statement. So let me go back to screen sharing here real quick. There we go. All right. So the last question we have E. It says the test resulted in a p-value of 0.0003. Based on the p-value, what conclusions should the student make? All right, so this is where I'm going to go back up to this hypothesis up here. So it says you have HO. So what this HO and HA are is our null hypothesis and our alternate hypothesis. So a null hypothesis is just the hypothesis that you're making, right? So the hypothesis that they're making is that the mean of the differences is equal to 0. So if I were to take all the differences, right, add them up, divide by 33, my n value, it would come out to 0. The alternate hypothesis is that the mean of the differences does not equal 0, right? So anything greater than or less than 0. So, so really, this is the hypothesis that they're making, and then the alternate hypothesis HA is just the opposite of the hypothesis they're making, or the null, right? So HO is the null hypothesis, or just the hypothesis that you're making. HA is the alternate of that hypothesis that you're making. So whenever we're looking at those things, I'm going to switch back off the screen sharing here to finish this cat off. Oh, there we go. All right. So if we're when we're talking about that, there's a few things that we need to know. They're given already that my p-value is 0.0003. So that's one of those things. The p-value is one of those things that you would normally have this long, complicated process to calculate, but they're going to give that to you on the test if they have a question on that. They're not going to ask you to calculate the p-value. You would need a calculator to do that, and they can't assume that, so they're going to give it to you. This is going to be one of those things they just kind of expect you to know how to work with. And my p-value is 0.003. So another thing that we need to know is a significance level. So a significance level is almost always either 1% or 0.01, 5% or 0.05, and 10% or 0.10. So it is extremely rare that you're going to see a significance level less than 0.01. It's not impossible, but you can safely assume that it's never going to be less than 0.01. And if we can safely assume it's never going to be less than 0.01, it sure as heck is never going to be anywhere near 0.0003, right? Or extremely rare that it'll ever be close to that, right? So when we're working with those things, and let me look at here. Okay, so if you look at the top here, I have that if your p-value is less than your significance level, then we have to reject the null hypothesis. So that means that the alternate hypothesis is for sure true, right? And then if my p-value is greater than or equal to my significance level, then we do not reject the hypothesis or the null hypothesis. So a fun way to remember that, that I'm not going to say in the video because there's a good chance that parents are going to watch this, and I wouldn't say it anyway because it's not appropriate, is if the p is low, you can reject the HO. And you can piece that together in your own mind and get a good little giggle out of that if you want. But so if the p is low, you reject the HO. If the p is high, you don't reject the HO. So really remember that word there. That's significant. That means we not rejecting the HO does not mean we necessarily accept it yet. If we would have gone on, we would have learned more ways, more calculations we would have had to have done in order to accept the null hypothesis. But for now, we just say that we can't reject it, right? So if it's low, right, we for sure can reject it. If it's not low, if it's high, then we just can't reject it yet. We would have to do more calculations in order to prove it. So if I'm looking at this question now, my p-value given is 0.003, right? Or 0.0003, yeah. And then we said my lowest, safest value to assume a significance level is 1% or 0.01, right? Well, if I'm assuming that the lowest possible is 0.01, right? Isn't 0.0003 lower than 0.01? So since 0.0003 is lower than 0.01, I can say that it's safe to assume that I would reject the null. So remember wording is going to be really important here, and being the difference between maybe getting a 5 and a 4 on a single question. So I would say that it's safe to assume that we can reject the null because we can't say for sure because we're not given a significance level, right? Now, if I'm given a significance level, so say if I was given in that question that there's a significance level of 0.01, then I would say I would for sure reject the null. since I'm not given that, I would say assuming that the lowest possible significance level is 0.01, I would say it's safe to assume we're going to reject the null. And then just show your work to prove that. So hopefully this is able to help you guys out some, give you a little bit more confidence with things. Again, go over that Fiveable website, the second link in the email, and go through all that stuff. There's a couple questions in there as well. Go over those. Ask me, email me. I'll be here. I can do another one of these. I don't mind making another one to help you guys out if you need it. I'm also available. I'll try to set up like a Microsoft Teams meeting if you guys want to do that to go over some questions and stuff. Like I said, anything you guys need from me, I'll be here. Again, just to reiterate from the email, I will be flying home to Louisiana on Friday. So I'll be at the airport in Wichita from, I think I board my plane probably at like 11:30 or something like that. So I'll be available to answer questions before 11:30. So I would say give me any last minute questions you may have before 11. And I will for sure be able to answer it before 11:30. Um, Outside of that, again, if I don't respond, it's not because I don't love you. It's just I'm in the plane and can't obviously check anything. Outside of that, those of you taking the test, I'd love to hear from you guys after. I have a long layover in Dallas, so if you want to reach out to me, I'd love to hear how it went, how you feel about it, and everything. I'm not sure when I'll have access to you guys' scores. I think it takes I think it takes them about a month and a half to come in. Hopefully we'll have some way to distribute that. I'm not sure again with the whole Corona thing, how that's going to look like, or it may take longer. I really don't know. But I will definitely, and I'm sure excuse me, shoot, what's the word I'm looking for? They'll communicate with you guys on, what that process is going to look like and everything. Yeah, again, make sure you're on that Fiveable website. Check the last 2 units that are on there because those are 2 units that we didn't get to cover that could pop up on the test. And again, I would really try to focus on this null hypothesis proving thing. Again, it's not a very tough concept to get, but I feel like they're probably going to pull a question from that on the test. So make sure you're going over that. And again, just make sure really skim over that Fiveable website and know how to find information on there, if nothing else. And again, refresh your memory on some of the things that we've done. They're not going to ask a ton of calculation questions. Any calculation questions they do ask, you could do on a simple little, your little elementary level calculators. But still know how to work with the information, right? And again, if you skim over that Fiveable website, know where to find things on there. Again, it's an open note test. You can go back and check on the website, all that fun stuff. So again, attached in this email that I send this link that I'm post this video to YouTube on, will be this sheet that I have my answers on. So I'll have a picture of that with you because I'm almost positive you're not going to be able to read it on the video. You know what I mean? Honestly, with as bad as my handwriting is, there's no guarantee you're going to be able to read it on the picture I send, but it will give you something to work with. So I'll send all this out to you guys here shortly. Obviously, if you're watching this, you've gotten it already. But yeah, I hope you guys are doing awesome. Look forward to hearing from you and seeing how this goes. And good luck. How do I stop this recording? There we go.